Okay, so today we are doing 8.1, which is going to go over some different characteristics of polynomial functions. Okay. The first thing we're going to talk about on the first 4 problems is the end behavior of these functions, which means what's happening on either end. Not what's happening in the middle of the function, but what's happening on either end of the function. And what determines this is the leading term of the function, which is the term that has the highest exponent. Okay, it's not always the term that's in the front. It's the term that has the highest exponent. Okay, so if the exponent of the leading term is even and the term is positive, that means the ends of the graph are going to both be going up. The most common one that we think about with this end behavior, what do x squared graphs look like? Right, they look like a parabola. And if the x squared is positive, look at the ends. What are they doing? Both going up. So that would be an even exponent and a positive term, right? What happens if the x squared all of a sudden was negative? Right, flips it across the x-axis or flips it upside down. So that would be an example of an even x squared, but the term is negative, which both sides would be going down. Okay, so it's not just x squared graphs, it's all, if the exponent is even, both ends are going to be going up. X to the 4th, x to the 6th, x to the 8th. If it's even, but it's negative, it's going to be going down on both ends. If your exponent is positive, if your exponent is odd and positive, you're going to start at the bottom and travel up throughout the graph. So this side will be going down, this side will be going up. The most common one that we see is that x to the 3rd. Remember, that's what x to the 3rd graphs look like. Okay, they start at the bottom and travel up. What if it's negative x to the 3rd? What happens because of this negative? It flips upside down, which gives it this end behavior. It starts at the top and travels down throughout the graph. So if your exponent is odd and that term is negative, this is going to be your end behavior. Okay, so let's look at some of these, starting at number 1. The function is f of x equals the square root of 11 x to the 3rd plus 2x squared minus 4x plus 5. So all I'm looking for is the leading term, which is the term that has the highest exponent. Which one has the highest exponent? This term right here. That's the term that's going to give this function its end behavior. Is its exponent even or odd? It's odd. Doesn't matter that this is a square root. All I'm concerned with is whether it's positive or negative. And this one is what? Positive. Which means what's its end behavior? It starts at the bottom and ends going up. In other words, it's traveling up throughout the graph from the left to the right. These are all 4 of these problems that are going to be talking about end behavior are going to be multiple choice with the 4 different types, both up, both down, this way, and this way. So you're just choosing the one that starts at the bottom and travels up. Number 2. P of x equals negative pi x to the 6 plus x to the 5th minus x to the 4th minus x plus 5. Okay, this graph is going to be doing all kinds of crazy stuff, but I definitely know what the ends of the graph are going to be doing. Go find your leading term. The term with the highest exponent is this one. Is this exponent even or odd? Even. And is this term positive or negative? Negative. So what's going to be happening at the end of both of these sides? Right, they're both going to be pointing down. Number 3. F of x equals negative 3.1 x to the 4th plus x to the 6th plus 0.1 x to the 7th. So like I said, the leading term is not always the term in the front. It's always the term that has the highest exponent. So here's the leading term of this polynomial function. The exponent is odd, positive, and the term is positive, which means starts from the bottom, travels up to the right. Number 4. Two plus 1/2 x to the 4th minus 1/7 x to the 3rd. This one's leading term in the middle, highest exponent. Exponent is even, term is positive, which means what are both ends of the graph doing? They're both going up, just like a positive x squared graph would be. All right, the rest of these problems in this section are going to be talking about the zeros of polynomial function. And what are the zeros telling you, whether it's an x-intercept or not, right? Whether it's crossing or touching the x-axis. So there is 2 different kinds of x-intercepts. There's this kind, where it crosses straight through the x-axis. There's also this kind, where it touches the x-axis and goes the other way. They're both zeros of the function, or they're both x-intercepts. What tells you what kind of x-intercept it is what's called the multiplicity of the factor. So let's talk about 2 things. So okay, so the 2 different kinds of x-intercepts. There's the x-intercepts that cross through the x-axis, and then there's the x-intercepts that touch it and go the other way. They call it tangent to the x-axis. This has to do with what's called the multiplicity of the zero, which means is the factor that it came from, is the exponent of that factor even or odd? We'll get to this. I just want you to have all these notes down before we get to these problems, and then you'll see how to find them. If the multiplicity of a certain zero is odd, and again, that's going to have to do, you're going to look at the exponent of the factor. If it's odd, it's a cross through kind of x-intercept. If it's even, it's going to be tangent to the x-intercept. So again, odd multiplicity is this kind, cross through. Even multiplicity is this kind, which is called tangent to the x-axis, which means touches it and goes the other way. Now, on number 5, all it's going to get me used to is if it gives me a number and asks whether or not it's a zero, that we can use what's called the substitution method. Doesn't matter if you're an x-intercept, it doesn't matter if you're crossing or touching. What are the y coordinates of both of those? Zero, right? That's what makes you be on the x-axis, because your y is 0, which is telling you you haven't gone up or down. Okay, so looking at number 5. F of x equals x to the third minus 8x squared plus 13x plus 6. And it wants to know, is 3 a zero of this function? Or in other words, is this function going to have an x-intercept at positive 3? What is f of x? The same thing as y. So what are your x-intercepts? What your x-intercepts? What are your y's? 0. So what this says is if it's a 0, you can make the y 0. If I replace these x's with this 3, does it make 0? That's exactly right. So replace your x's with 3. So you have 3 to the third minus 8 times 3 squared plus 13 times 3 plus 6. You can just punch that in your calculator to see if when you replace all those x's with 3's. Let's see, 3 to the third minus 8. And I'm just entering it exactly like this says, minus 8, open parentheses, 3, close, square it, plus 13, open parentheses, 3, close, plus 6. So when you type all that in your calculator, does the answer hit 0? And it does. Which, oops, 0 doesn't equal 3. 0 equals 0, which means, is this an x-intercept or a 0 of this function? Yes. Yes, it is. If you get any other number here, it doesn't matter what it is, then the answer would be no. Because what you're doing is you're finding what the x is when the y is 0. Okay? Number 6. Before we do number 6, let's talk about some different kinds of factoring. Just to give us some background. If you have something like this, x squared minus 25, and you are asked to factor that. The type of factoring that this is called the difference of two perfect squares. Why? Because both of these terms are perfect squares. What times itself can you multiply together to get x squared? Not you're in. What times itself gives you x squared? X. Yeah. What times itself gives you 25? 5. If there's a minus in between those terms, you can factor this by the difference of perfect squares. So just like y'all said, what's going to come here and here to get x squared?
X plus 5 and x minus 5.
Good. So I have 5 and 5 to get the 25, and your signs are always different. One positive, one negative. Doesn't matter where the positive and negative go. So that's how you can factor anytime you see a difference of perfect squares. So x squared minus 49 would be what?
X plus 7, x minus 7.
Yeah, using the sevens, right, for the 49. Okay, so I just wanted to give you a little bit of background history before we do number 6. Number 6 says, find the zeros of the function and state the multiplicity of each. So you have x squared minus 4 squared. We'll talk about this in a minute. But what's inside here, I can factor. If you, inside your parentheses, if you have an x squared, you're going to try to factor what's inside that parenthesis. And just like what we were just practicing, 4 is a perfect square, right? How do you get it? 2 and 2. So you're going to have x plus 2 and x minus 2. Now, just because I broke these apart like this, that doesn't affect. They are still both squared. Once you are completely factored like this, I can't do it. I can't factor what's inside here anymore. If your x is just an x, you're not going to be able to factor it anymore. You set your factors equal to 0. And solve them for x. That's going to give you your zeros. If you factor, set your factors equal to 0, solve them for x. So here, subtract 2 from both sides. So x equals negative 2. Here, add 2 to both sides. So x equals 2, which is telling me that if I put this in my y equals and graph it, it's going to have x-intercepts at negative 2 and positive 2. Now, what kind of x-intercepts are these? Are they cross through or are they tangent, which comes from the multiplicity? That's what those are. The exponent of the factor. Right. So the multiplicity of each of these are both 2. Which is the end of that question. It's not going to ask you anything else. But yes, that means that these are tangent, which if I graph this, that means that positive and negative 2, it's going to come touch the x-axis and go the other way. So we're finding zeros and then the multiplicity of those zeros on the next few problems. All right, number 7. F of x equals x to the 6th times x minus 1 squared times x plus 7. And we're going to find the zeros and the multiplicities of this function. Now, this one's actually even better because all the factoring has already been done, right? Look inside your parentheses. Are your x's just x's? Yeah, then your factoring's done. There's no difference of squares or trinomials to factor or anything like that. So what did we do on that last problem after we did that factoring? What did we do with each factor? Set it equal to 0. You've got 3 factors that have x's here. This is your multiplicities. So this factor is just x. Set it equal to 0. This factor is x minus 1. Set it equal to 0. This factor is x plus 7. Set it equal to 0. Then solve them each, get their x's by themselves. This one's just already done. This one I need to add 1 to both sides. X equals 1. And this one I need to subtract 7 from both sides. So x equals -7. So there's your zeros. What's this one's multiplicity? 6. This zero's multiplicity is 2. And this zero's multiplicity is, what's that exponent? You just don't see it. 1. Now, it does ask you to enter your answers weird on this one. It's going to say the smallest zero. So 0, 1, or -7. Who's the smallest? -7 has a multiplicity of 1. The middle zero between these 3 numbers would be 0. Its multiplicity is 6. The largest zero is 1, and its multiplicity is 2.
Gotcha.
So it's just going to ask you to so my zeros are 0, 1, and -7. Who's the smallest? -7. So if you wanted to, you could actually just put them in order, right? From smallest. So -7, 0, and 1 is how they would be entered. And then again, their multiplicities are the exponents from the factor that they came from. So it doesn't ask me, but what's going to happen on the x-axis at 0? What's it going to do? Cross or touch? Touch, right? Because the x multiplicity is even. At 1 on the x-axis, it's again going to touch it and go the other way. What's it going to do at -7 on the x-axis? Cross through it because its multiplicity is odd. Number 8. All right, this one's function is f of x equals -6 times x minus 3 to the 4th times x plus 1 to the 3rd times x squared. All right, looking inside each of those parentheses, x is just x in all of them, right? So again, just like the last one, the factoring is done. This I don't set equal to 0. Why not? It doesn't have a x to solve for, right? If you're going to be a 0, you've got to have an x to solve for. So I just ignore this if I'm just finding zeros. This factor. So x minus 3 equals 0. X plus 1 equals 0. And x equals 0. Solve them for their x's. So add 3 here. So here, x equals 3. Subtract 1s. So here, x equals -1, and this one's already done. What's the multiplicity of this 0? 4. Of this 0, 3. And of this 0, correct. Okay, so when the function is already in its factored form, there's not a lot to do. You're just setting the x's equal to zeros and solving them to find the x-intercept and then saying what the multiplicity is by just looking at the exponent. But on number 9 and 10, f of x equals x to the third minus 4x squared minus x plus 4. It says the zeros of the function are blank and each zero has a multiplicity of blank. It's not in its factored form, right? You don't see factors with x's that you can set equal to 0, which means we have to do the factoring on our own. So the first thing I would look for is anything that's in common with all 4 terms. But is there something that all 4 have in common? No. Okay, it kind of looks like it, but there's not anything that is in common with all 4 terms. If you have 4 terms and nothing is in common, you're going to do what's called factoring by grouping, which means you're going to put the first 2 in their own group and the second 2 in their own group. And you're just going to look at each of the smaller groups and take out what's in common from each of the smaller groups. So looking at this first group, which is these first 2 terms, what do they both have in common? X's, right? You want to pull out as much x as you can, which means I can actually pull out x squared, right? They both have x squared in them. So pull out the x squared and put in parentheses what's left, which means if I take an x squared out of each of these, what's going to be left in your first term if you took out x squared, but you started with x to the third? Just an x. Minus, what's going to be left in this term? Right, so x minus 4. I'm going to do the same thing to that second group. And when I do that, I want what's left in its leftover parentheses to be exactly what's in this one. Now, I can see x's in both of these. I don't see anything in common with that second group. There's actually 2 numbers that you can pull out of everybody, a 1 and a -1, right? Because you can divide anything by 1 and you can divide anything by -1. So to decide if I need to pull out positive or -1 just means, do I need to change these signs in order for this parenthesis to match? Yes. What's this x? Negative. What's this x? Positive. That means I do need to change my signs. So what kind of 1 changes signs? -1. So pull out a -1. You have to pull something out. If there's nothing in common, then it's either a 1 or a -1, depending on whether or not you need to change these signs to match these. So if I divide these both by -1, I'll have positive x minus 4, right? Because positive over negative gives me -4. So now what you have created is this in common, which means now I can pull it out. Since it's in common with both of them, I can pull out that whole x minus 4 parenthesis and put in parentheses what's left. So if I pull out, just like when I pulled out up here, what did I do? I divided by what I took out, right? So what am I taking out? X minus 4. So I'll divide each one of those by that x minus 4 that I took out, which means that cancels that. That cancels that. So what are you left with in your second parentheses?
X squared minus 1.
X squared minus 1. So this one's done since my x is just an x. This one is a perfect square. How do you get 1 using the same number? 1 and 1. So I'm done with this. So I'll just bring it down. This is a difference of perfect squares again. X and x for x squared plus 1 and minus 1 to get that -1. So are all my x's just x's now? Yeah, which means I'm done factoring. So now when I'm done factoring, what do you do with each factor to find its 0? Set it equal to 0. and solve them for x. So add the 4s here. So x equals 4. Subtract 1s. So x equals -1. And here add 1 to get x equals +1. So the zeros of this function are 4, -1, and +1. What are the multiplicities of each of those? That means go back to the factor that they came from. What are the multiplicities of each of them? 1. Okay, now what I'm going to do is put this function just to show you what we've been doing. So I'm going to put this function in my y equals in bracket. Because what should be happening at 4, -1, and +1? Since those zeros all have multiplicities of 1, what should be happening at all those spots on the x-axis? Should be crossing through. Okay, so I'm going to, in my y equals, put in that function, x to the 3rd minus 4x squared minus x plus 4. And then graph it. Right? There's my -1, crosses through. +1, crosses through. +4, crosses through. So that's what you're doing when you're finding the zeros of this function. And look at the end behavior. What is my end behavior? My exponent is odd, and that term is positive. All graphs that have odd positives as their leading term start at the bottom, whatever in the middle, but end up going up on the right. One more thing while I have this up here, because this is going to come into play in the next section. What would be my y-intercept of this function? How do you find the y-intercept? You replace all the x's with what? Zeros, right? Because if you're on the y-axis, what have you not done? You haven't gone left or right. You're still on the y-axis. Where does it look like this is crossing the y? 4. Look, if you replace all these x's with zeros, what are you going to be left with? That 4 right there, right? Because if these are all 0, your y is going to be 4. Okay, we're going to do a lot more of that in the next section. I just wanted to point that out while I had that graph up there. Okay, number 10. Same kind of problem, finding zeros when you have to factor f of x equals 2x to the 3rd minus x squared minus 50x plus 25. Four terms. Nothing's in common with all 4 of them, which means let's group. In my first group, how much x can you pull out?
X squared.
Squared. Good. So if I pull out x squared from each of these, if I pulled out x squared from this first term, what's left? 2 and an x, right? Minus, now I'm not left with nothing, right? Because look, just look at the fraction. What is x squared divided by itself? 1. So when you pull out what is already there, you're left with 1, not nothing. So remember, what do we want this leftover parentheses to be? The same as this first one. So looking at these numbers, if that's going to end up being a 2, what's in common with 50? The biggest thing that's in common with 50 and 25? 25. So I can divide both of those by 25. Now I just need to determine whether it needs to be a positive or a negative 25. Which means, do I need to change the signs to match these or not? So what is this x? Is it positive or negative? It's negative. What is this x? Positive. So do I need to change signs? Yeah, which means I pull out a negative. Pulling out a negative is what changes signs. So I'm dividing both of these by negative 25. Which does make this positive 2x. Positive 25 over negative 25 is negative 1. Right? These are the same, which means now what are you going to do? Pull them out. Right? It's a greatest common factor. You're just taking out an entire parentheses. 2x minus 1. Now I could do, put it up there and divide it, but what your leftover parenthesis is just going to be that. X squared minus 25. Is this factor done? Yeah, it's x is just an x, but is this factor done? No. No. X squared and 25 are both perfect squares. So I'm just going to bring this one down. This one's a difference of squares. X and x for x squared. What are you using for the 25? 5 and 5. Your signs are always different from each other. It doesn't matter where the plus and minus go. So now I'm done factoring. So how do you find the zeros from your factors? All right, set them equal to 0 and solve them for x. So on this one, I need to, first of all, add 1. So 2x equals 1, and then divide by 2. So x equals 1/2. On this one, I just need to subtract 5. So x equals negative 5, and on this one, add the 5s. X equals positive 5. So your zeros are 1/2, negative 5, and positive 5. What are the multiplicities of each of those? Ones, because here's the factors that they came from. And they all had multiplicity of 1. All right, the last two problems are going to give us a statement, and it's going to ask us about the multiplicity, or if the 0 is tangent to the x-axis or if it crosses the x-axis. So we need to know the multiplicity rules again, right? Even multiplicity means what? Tangent. Odd multiplicity means cross. Yeah. All right, the function e of x equals x minus 5 to the 4th, x plus 2 to the 3rd. So there's my function. It says this crosses x-axis at 5, 0. So the 0 is 5, right? The x-intercept. So which of these two factors do you think that this x-intercept came from? This one right here, right? Because if you set x minus 5 equal to 0 and solve it, you get that x equals 5. So it is an x-intercept, but its multiplicity is what? 4. What kind of a number is 4? Even or odd? Even. So this one has even multiplicity, which means it does what? Tangent. Even multiplicity is tangent to x axis. So it would be false because its multiplicity is 4, which is even, which means it's tangent to the x axis at 5. All right, last one. It's just like this. I'll put it up here while I take roll. E of x equals x minus 8 to the 7th, x plus 5 to the 10th, and this one says it is tangent to x axis at -5, 0. So is this true? Yes, yes, this one would be true because at this 0, it's 10, which is even, which means tangent.